Hello everyone. In the last video, we started about the proof of work, the theoretical concepts involved. And in this video, we're going to see a toy example on proof of work. Now, why am I calling it a toy example? You will understand it as we go ahead in the slide deck. So let's just start with the example, okay? Uh, Not thinking about if it's a toy example, if it's a real example. Let's just start with the example at least, okay? So what does the example say? So first thing is you need to find out the hash value such that it starts with 10 and this is our target space. And what is the data given to us? The data given to us is make America great again. Okay. So what is our approach in finding nonce? We start with the value 1 and then just keep on incrementing it one by one to get the hash value that starts with a 0, right? So we take up the hash, the SHA-256. And what do we take the hash of? We take the hash of nonce as well as the data input string. The input string here is make America great again. Appending it with 1, we get the hash for this and it does not start with 0. We increment it, take it to 2, 3, 4 and so on and so forth. And then finally on our 20th attempt, we find the hash value such that it starts with 0. So the 0 input, the one for which the hash value it started with 0, the input is 20, make America great again. So number of zeros that I want in my output is known as the difficulty. So the more the zeros you want your string to start with, more is the difficulty that you have aimed for that particular puzzle, right? So now we readjust the goal and we say, okay, I want the hash that starts with 2 leading zeros. Now you keep on going again from 21, 22, 23, and then on your 120th nonce you get the answer. So by adding just 1 unit of difficulty, by just saying that I want 10 more prepended to my hash, the time taken increased exponentially. So let's just assume if the goal is to have 4 leading zeros, then the first such occurrence will be found when the nonce is 69817, an exponential increase. And this is called the proof of work. This is when you say that you need a high energy consumption in this case, because you need high computing resources for this, because with one difficulty level being raised up, your effort, your time taken, it increases exponentially out there. So once the solution is found out, when the node immediately sends all the information, it broadcasts the information to all the nodes, and then each of the participating nodes, the ones who could not get to this answer, can just immediately verify. Because let's just say I give you an arithmetic equation to solve. Finding out the answer to it is difficult, but when I say you that, hey, the answer for this is x is equal to 0, you just have to plug in the value 0 in place where all the x's are there, and then just calculate it. And it's easy, right? So that is it. And then each of the nodes participating can immediately verify, and the distributed consensus agree that it was the winning node and hence award it with the newly created bitcoins. And the example goes by 20th, we get 10, one level of difficulty. Then in the 120th attempt, you get 2 zeros. And then when you forward it down to 69817, you get 4 zeros prepending your hash. And then let's just come to your steps. The proof of work steps, they say that you have to collect transactions from the transaction pool, because you're all waiting for the transactions, right? And then when you have a transaction, you get them all together and build a complete block such that its size does not exceed 1 MB. So it's like you can seal a box only when the size is 1 MB. If the box exceeds 1 MB, you cannot take up the last commodity you took. Make sense? Then that is why I called it a toy example, because the actual hash that you have to take is actually of the block header, and the block header contains version, previous block hash, Merkle root, timestamp, difficulty bits, and nonce. What is the Merkle root? It is the, now you'll be asking me, where is the data? You told me in the last example you'll be having data to hash on. Merkle root is hash of all the transactions that are there in that block, the block that I'm going to propose. Make sense? And you need to twice hash it. It's like you take the hash of all this and then you again hash it all, right? It's just for your security purposes. And then you have to compare the result, and if you get the expected number of zeros, well and good, you broadcast your answer to the entire participating nodes. But if not, you increment your nonce and just repeat the steps again, right? So if it says, if to technically speak, the hash value is compared with a target, and the target is a very large number and known to every Bitcoin client, because everybody has to get the target, right? And even if I don't get it, the one who gets it and broadcasts it to the network, I need to verify it, right? So for the block to be accepted, the hash value has to be less than the target. And when I say the hash value has to be less than the target, so just think the target is something like triple zeros, F, 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 F. Remember your hexadecimal number, F is the greatest one. So triple zero, F, 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 F. Now, if I get a triple zero value, if my value starts with triple zero, whatever it is, whatever it is then followed by, it is going to be smaller than triple zero, all Fs. Do you get that? So that is why we do it simpler. We just say that I want this many number of leading zeros. This is my expectation. This is what you need to get me in order to, in order for me to accept your block. So once the miner finds a winning block, then it sends it to all the participating nodes, broadcasts it in the network, and then the other nodes, the participating nodes, they can re-verify it if the block proposed is correct or not. And once all agree, then the node which calculated the winning block is rewarded with the newly created Bitcoins. The winning block is first checked by each node individually for a long checklist of items, right? For all the transactions, for the nonce value, and everything, right? If a miner is adding 10,000 Bitcoins in Coinbase transaction, it is immediately rejected by all. So, if I just make up a wrong transaction, I will get immediately rejected off at the moment. So as time progresses, more high computational nodes join. Do you know what this is trying to tell to you? We have set up the block creation time as 10 minutes. You need to take 10 minutes to create a block, to find that nonce number actually. So as it is, as the time is progressing, the high computational nodes, the one with the high computing power, they just participate in. And that is why we need to increase the difficulty after every 2 weeks or after exactly 2016 blocks. Why? So that it at least takes 10 minutes to solve the puzzle. Do you get it? So increase in difficulty means what? Your target decreases. And if two nodes, give you two blocks at the same time, and they're both right, which one are you going to check in? Which one are you going to actually consider? The one that has more computational power, because that is what it is, your proof of work. So ever since the difficulty has been increasing, the current difficulty of the Bitcoin network can be found here. As the hash of the Genesis block has 10 leading zeros, and this so for the current difficulty is between 17 to 19 zeros, and this could have been changed by now. So it takes a huge computing power to calculate the nonce, right? So that is what I mentioned, that more a person who is ready to put in more computational power is the one whose block is actually going to be accepted down the lane. Advantages, we studied about selecting a random node. So here there is nothing like a random node. The one who competes and wins is one who gets to propose the new block into the existing blockchain. Nodes independently compete by attempting to solve hash puzzles. Once in a while, one will succeed and then will propose the next block. Result is what? The system is highly decentralized. No one gets to decide which node proposes the next block. It's just the nodes. They are competing, and the one who wins gets the sole authority. With it, that's it. If you have any questions, please post them in the comment section. If you have any concerns, go ahead, fill in the G forms if you want me to re-clarify any topics, and if you want me to take in any other subjects. With this, I will take your leave. If you like the video, if you could understand the video, just go and like and subscribe. Bye-bye.